Hi everyone. In this video, I'm going to go through a half dozen different probability problems that are based on combinatorics and permutations. And again, for this video, for the most part, I'm not actually going to pull up my calculator to do the calculations. Some of them we'll be able to do by hand. Some of the ones in the middle, we'll just sort of skip that step for the sake of time. But at the end of the video, the last question I'm going to show you how to do on the calculator, just in case you don't know that your calculator can reduce fractions for you. Probabilities are fractions, and so it's really helpful to be able to get the fraction reduced correctly without needing to manually divide top and bottom and so on. Okay, so let's jump in and see if we can figure this out. What is the probability of rolling a sum of 8 on 2 dice? And there's actually two completely different methods of approaching this problem. Method one is to get your sort of outcomes you want. In this case, getting an 8, right? How many ways can you roll an 8? Divided by total number of outcomes. Now, this method only works if your likelihood of every single outcome is exactly the same. And we're just going to assume that these are fair dice, right? If they're weighted dice, then this whole thing goes out the window. But we're going to assume that each of the 2 dice has a 1 in 6 chance of getting each of the faces. So in this case, we need to figure out how many ways you can roll an 8. And I think, you could do a big table or whatever, but, there aren't that many. If you roll a 2, then you have to get a 6. If you roll a 3, then you have to get a 5 on the second die. If you roll a 4, then it has to be double 4s, 5, 3, or 6, 2. And those are the only 5 ways you can get an 8. If you roll a 1 on either of the dice, then you're not going to get a sum of 8. So in total, there are 5 options. Out of, on 2 dice, each of the die has 6 faces, so 6 times 6 is 36 possible options total. Okay, so that's not too bad. The other way is to actually split out die number 1 from die number 2. And this is something called conditional probability. And basically the idea is we'll figure out the likelihood of getting one of the results that could give us an 8 on the first dice roll, and then figure out how many ways or what the probability is of getting the exact number we need on the second dice to get a sum of 8. So our first die, you basically can't get a 1, but any of the 5 other faces will be fine, right? If you roll a 2, that's fine. A 3 is fine. A 4 is fine. A 5 is fine. Or a 6 is fine. So your first dice roll, you can get anything except for a 1, and you could still get an 8. Now, based on rolling a 2 first, you have to get a 6. If you roll a 3 first, you have to get a 5. If you roll a 4 first, you have to get a 4, and so on. No matter which one you roll first, there's only one option left that will give you a sum of exactly 8, which means it's exactly a 1 in 6 chance on the second die roll. And you multiply those two together, and you get 5 over 36. Okay, same number. Let's try another dice question. So in Dungeons & Dragons, players often roll multiple dice at once and add up the total result. To make reading the rules more simple, the D&D rules shorten this to XDY, where X is the number of dice to roll and Y is the number of faces on each die. So 2d6 means roll 2 6-sided dice and add them up. So what's the probability of getting a sum of 4 when 4d20 is rolled? Conveniently, this is why I chose the number, obviously, 4 is just 1 plus 1 plus 1 plus 1. And so there's only one way you can get that. You need 1 on all 4 of the dice. So if we use method 1, then our number of the number of hits we have, right, the number of outcomes that we want is only 1, the 1 1 1 1 option. And in total, well, there are 20 faces on the first die, 20 on the second, 20 on the third, 20 on the fourth, which is 1 over 20 to the fourth, which is we can do not 2. This isn't too hard because that's going to be 4 zeros, and then 2 to the fourth is 16. So that's 1 in 160,000. Okay, cool. And this, you could also just do the four dice separately, right? Number 1, number 2, number 3, and number 4. And the first die, you have a 1 in 20 chance of getting the 1. The second die, you have a 1 in 20 chance of getting the 1. And the third die the same, and the fourth die the same, which is 1 over 20 to the fourth, which is the same thing. 1 in 160,000. Okay, let's try this one. So this is more of like a fundamental counting principle problem that's turning into a probability question. Okay, so unbeknownst to each other, Bella and Taylor are both planning a summer trip starting in Whistler, stopping in Edmonton, and ending in Saskatoon. Okay, there are 2 route options to pick between Whistler and Edmonton, and there are 5 options between Edmonton and Saskatoon. 1, 2, 3, 4, 5. Okay. Bella carefully researches the options and selects the best route. Taylor thinks it's more exciting to let chance decide and selects a completely random route. What is the probability that Bella and Taylor take the exact same route? Now, there's a few ways to think about this question, but I think the easiest way to think about this is that really the route that Bella picks doesn't really matter for the purpose of this problem. Maybe she picked the top route and she picked the 4th route. I mean, it doesn't matter, right? She picks a particular route that happens to be the best route. What's the chance that Taylor happens to pick that exact best route? And I think sort of the method 2 way, where you think of these 2 choices separately, is probably the easiest way to figure this question out. So the first option, there's a 1 in 2 chance that Taylor chose the right route, right? There's only 2 options, 50-50. The second option, there's 5 choices. She needs to pick the right one. So 1 out of 5. Multiply those together, and you get 1 in 10. The method 2 way, though, isn't too bad, right? Our total number of routes is 2 times 5, and there's only 1 best route. So it's just 1 in 10, right? So, I don't know. Maybe one way is, I'm not sure which way is better than the other. They both make sense to me. Hopefully they both make sense to you as well. All right, let's do a couple word, subset ones. And the difference between these 2 versions is whether or not repetition is allowed. And when repetition, so in this first one, repetition is allowed, which makes, it makes this an easier problem, I think. So we've got the word gambit, and it's worth taking the time to double check that you only have each letter once. I know it seems a little bit silly to do this every single time, but trust me, it catches so many mistakes. Okay, so we've got 6 letters. They're all unique. And what's the probability of getting A-T-A-A? Well, if you do the method 2A, the fundamental counting principle type way, I think this makes a lot of sense. There's 6 choices. If you randomly select a letter, what's the chance you get an A? Well, there's a 1 in 6 chance. What's the chance you get a T? Well, 1 in 6 chance. In fact, every single specific letter choice has a 1 in 6 chance of happening. So this is 1 in 6 to the 4th, which is the same as 1 over 6 to the 4th. Whatever 6 to the 4th is, doesn't matter. 1286, I think. Anyway, it doesn't matter. You can put that in your calculator yourself. Or you can figure out your number of ways of getting exactly what you want. So there's one way of getting our hit, or whatever you want to call it, getting ATAA over, well, for each letter there's 6 choices, 6 to the 4th ways of choosing 4 letters. Okay, and that works out obviously to the same thing. This one, same question, just no repetition is allowed. And it's longer words, wanderlust, but I think it's worth taking the time to make sure that you only have each letter once. One, E, R, L, U, S, and T. And sure enough, none of my letters are repeated, so I've got 10 letters with no repeats, okay? And the difference here is no repetition is allowed. Okay, so we want R-E-T-W. So again, there's 2 methods, R-E-T-W. Now, it's slightly different in this case because our probabilities are going to change as we go along. So what's your chance of getting an R? Well, there's 10 letters, and there's only 1 R, so there's a 1 in 10 chance, and that R is gone. Well, since the R is gone, there's now 9 choices left for the E. And then once the E is gone, then there's 8 choices left and then 7 choices left. Okay, so you can multiply that across if you like. Or there's 1 RETW over, out of the 10 letters, we want to permute 4 of them total. Okay, cool. And either of those will get you the correct answer. Okay, now this is the one I want to do on the calculator because this is going to give us kind of an ugly fraction with like we're multiplying big numbers together, and reducing the fraction your calculator can do for you. So why bother doing it by hand when you don't have to? Let's read this question. A container has 9 indigo balls and 4 white balls. If 8 balls are selected at random, what is the chance that 5 indigo balls and 3 white balls are selected? Okay, so I think that we just want to do the number of options ways for this. I'm not really sure how you'd separate it out into individual choices. In fact, separating it out into individual choices is a much, much harder problem. Like what happens if you pick all 5 indigo balls at once? Then there's no choices left for the rest. It becomes a mess. So you don't want to go down that route. We're going to want to do this the counting way. So basically we want to do our number of hits. So number of ways of 5 indigo and 3 white is, of the 9 indigo balls, we want to choose 5. And of the 3 white balls, of the 4 white balls, we want to choose 3. And our total ways of choosing 8, so we want to choose 8 total, and we have a total of, add those up, there's 13. And so there's your probability. But like this are going to be pretty big numbers. So let's do this separately and see what we get in our calculator. Okay. So here we go. Oops, had that up already. Okay, here we go. So 9 math choose 5 times 4 choose 3 is 504. Okay, and then 13 choose 8 is 1287, and that's going to reduce using mental math tricks. Like there's a divisibility trick for 3, so I can tell sort of at a glance that this is divisible by 3. But it takes time to reduce this. So let's not reduce it by hand. There's a few ways we can do this in our calculator. The simplest way for a lot of students is to just do the division. And then the very first option on the math menu is turning your answer into a fraction. Boom. So that's 56 over 143. Okay, there's other options though. If you don't have a graphing calculator, that's okay. There's another button that exists on Scientific Calculator, which is basically used instead of a division key. So you do 504. On this calculator, it's at the bottom of the number menu. So math, number, and then the last option is D, N/D. And you basically use that instead of a division key, and it lets you do a fraction. And on a Scientific Calculator, the fraction key you basically use in place of your division key is usually A, B, C, or another one I've seen is A/B. Usually there's something like that that just looks like a fraction, and you can just use it in place of the division key on your calculator, and it just works. And then, you don't need to do this in separate steps. Like you could, second entry, second entry, second entry, second entry, second entry. There we go. So you could take your original thing, like instead of doing it in 2 steps, you could have just put brackets around your whole numerator and then done your math division key by your whole denominator. 13 choose 8. And that also works.